Imagine a world where artificial intelligence helps us make truly equitable decisions, revolutionizes healthcare for everyone, and unlocks unprecedented opportunities across society. That's the profound promise of AI, a technology poised to reshape our future. But what if the very systems we're building, designed to be objective, are inadvertently perpetuating or even amplifying existing societal inequalities? This isn't just a theoretical concern. It's a critical challenge facing the entire AI community. For tech enthusiasts, ML engineers, data scientists, ethics researchers, and AI students alike, understanding and mitigating AI bias is paramount. This video will deconstruct the complex issue of AI bias, providing practical insights and best practices for building fairer, more robust, and ethically sound machine learning models. We'll explore precisely how bias infiltrates AI systems, examine its tangible real-world consequences, and outline actionable strategies you can implement to foster more equitable AI. Let's dive into this essential discussion. AI systems are fundamentally pattern recognition machines. They learn, adapt, and make predictions based on the vast datasets they are trained upon. The inherent challenge lies in the fact that these datasets are often historical reflections of our world, which, unfortunately, includes deeply embedded societal biases related to gender, race, socioeconomic status, geographic location, and more. Consider a scenario. If an AI model designed to identify successful leaders is predominantly trained on images and profiles of white men in executive roles, it will inevitably learn to associate leadership traits with those specific demographics. This isn't a malicious intent on the part of the AI. Rather, it's a direct, logical outcome of the skewed data it was fed. The AI simply optimizes for the patterns it observes, even if those patterns are rooted in historical discrimination. These learned biases can lead to profoundly unfair and discriminatory outcomes in real-world applications. A stark example is found in facial recognition technology. Numerous independent studies, including those by the National Institute of Standards and Technology, NIST, have consistently demonstrated that these systems exhibit significantly lower accuracy rates when identifying individuals from marginalized groups, particularly women of color. This disparity has led to alarming instances of misidentification and wrongful arrests, highlighting the severe human cost of biased AI. The problem extends far beyond facial recognition. AI is increasingly integrated into critical decision-making processes across various sectors. Loan applications, hiring processes, criminal justice risk assessments, and even medical diagnostics. If the foundational data used to train these systems contains historical or systemic biases, the AI will not only perpetuate, but often amplify those biases, leading to decisions that are inherently unfair or discriminatory against specific populations. This amplification effect occurs because AI can scale biased decisions at an unprecedented rate, impacting millions. Let's delve into specific, tangible examples to fully grasp the pervasive and often devastating impact of AI bias. In the financial sector, AI algorithms used for loan approvals have been shown to perpetuate historical redlining practices. They can assign higher interest rates or outright deny loans to minority applicants, even when their creditworthiness and financial profiles are demonstrably comparable to their white counterparts. This isn't always explicit discrimination. Often, it's the algorithm picking up on proxy variables like zip codes or educational institutions that correlate with historical socioeconomic disparities. In the realm of employment, AI-powered resume screening tools, designed to streamline hiring, have inadvertently filtered out highly qualified candidates based on gender or ethnicity. A well-documented case involved Amazon, which famously scrapped its experimental AI recruiting tool after discovering it systematically favored male candidates. The algorithm had learned from historical hiring data, which predominantly featured male engineers, leading it to penalize resumes containing words associated with women, such as women's chess club captain. This illustrates how historical workforce imbalances can be codified and perpetuated by AI. The consequences extend critically into the criminal justice system. AI algorithms, such as those used to predict recidivism, the likelihood of an individual reoffending, have been shown to be significantly biased against Black defendants. Studies, notably by ProPublica on the Compass algorithm, revealed that Black defendants were nearly twice as likely as white defendants to be falsely flagged as future criminals, while white defendants were more often falsely labeled as low risk. These biased risk scores can directly influence judicial decisions regarding bail, sentencing, and parole, leading to harsher penalties and perpetuating cycles of inequality for already vulnerable communities. Beyond these, AI bias manifests in healthcare, where diagnostic tools trained on predominantly white patient data may misdiagnose conditions in people of color, particularly dermatological issues. In education, AI-driven assessment tools could inadvertently disadvantage students from certain backgrounds if their learning patterns or language use differ from the norm in the training data. These aren't isolated incidents. They are systemic issues that underscore the urgent need for ethical considerations in AI development. The scale of these impacts demands our immediate attention and proactive intervention. Understanding the root causes of AI bias is crucial for effective mitigation. Bias can infiltrate an AI system at multiple stages of its life cycle, from initial data collection to final deployment. Firstly, the most common culprit is biased training data. If the dataset used to train an AI system does not accurately or proportionally represent the diverse population it is intended to serve, the AI will inevitably develop blind spots or skewed perspectives. This can happen due to historical underrepresentation in data collection, or simply because certain demographic groups are less likely to be captured in existing datasets. For instance, if a voice recognition system is trained primarily on male voices, it will perform poorly on female voices. Secondly, biased data labeling introduces another layer of complexity. Even if raw data is diverse, the process of annotating or categorizing that data can inject human biases. If the individuals labeling the data hold unconscious biases, they may inadvertently assign labels that reflect their own stereotypes or assumptions. For example, if human labelers are more likely to associate certain job titles with specific genders, the AI will learn these biased associations regardless of the actual content. This human element in the loop is a significant, often overlooked source of bias. Thirdly, algorithm design and feature selection play a critical role. The specific features chosen for an algorithm and the way the algorithm is structured can inadvertently amplify existing biases present in the data. Using proxy variables, which are seemingly neutral but correlate strongly with protected attributes, like using zip codes as a feature in a loan application, which can perpetuate historical redlining, is a common pitfall. The mathematical models themselves, if not carefully constructed and evaluated for fairness, can inadvertently prioritize overall accuracy at the expense of equitable performance across different subgroups. Finally, bias can also emerge during deployment and real-world interaction. Even if a model is relatively unbiased in its development environment, the way it is integrated and used in a specific context can lead to unfair outcomes. For example, if a facial recognition system, even one with decent overall accuracy, is deployed disproportionately in areas with a high concentration of a particular demographic group, any residual bias, however small, can lead to a higher absolute number of false positives for that group, exacerbating existing societal inequalities. The context of use matters immensely. The good news is that AI bias is not an insurmountable problem. It is a challenge that can be addressed through a combination of technical solutions, robust methodologies, and a commitment to ethical development. Building fairer AI requires a multifaceted approach, integrating best practices throughout the entire machine learning pipeline. The first critical step is to prioritize data diversity and representation. We must actively ensure that the data sets used to train AI systems are truly representative of the entire population they are intended to serve. This often involves proactive efforts to collect data from underrepresented groups, addressing historical data deserts, and employing techniques like data augmentation to balance skewed distributions. Data auditing tools can help identify imbalances before training begins. Secondly, implementing bias detection and mitigation techniques is essential. There are a growing number of sophisticated tools and algorithms designed specifically to identify and correct biases within training data and AI models. Techniques such as adversarial debiasing, reweighting, and resampling can be applied during training to reduce the model's reliance on biased features or to ensure more equitable performance across different demographic groups. Post-processing methods can also adjust model outputs to achieve fairness metrics. Thirdly, transparency and accountability are paramount. We need to move towards more explainable AI, XAI techniques that allow developers, regulators, and the public to understand how AI systems are making decisions. This involves developing methods to interpret model predictions, identify influential features, and trace decision pathways. Furthermore, Establishing clear accountability frameworks ensures that developers and deployers are responsible for the ethical implications and societal impact of their AI systems. Regular audits and impact assessments are crucial. Fourthly, fostering diversity and inclusion within the AI development community itself is not just a moral imperative, but a practical necessity. Teams composed of individuals from diverse backgrounds, cultures, and perspectives are far more likely to identify potential biases, anticipate unintended consequences, and develop more robust and equitable solutions. A diverse team can challenge assumptions, bring different lived experiences to the table, and ensure that fairness considerations are embedded from the very inception of a project. Finally, adopting fairness metrics and continuous monitoring is vital. Beyond traditional accuracy metrics, AI developers must incorporate fairness metrics, e.g., demographic parity, equalized odds, individual fairness, to evaluate model performance across different subgroups. This requires ongoing monitoring of deployed models to detect concept drift or emergent biases that may arise from real-world interactions, allowing for timely intervention and retraining. The future of artificial intelligence hinges critically on our collective ability to address the pervasive issue of bias. By proactively committing to building fairer, more transparent, and ethically sound AI systems, we can truly unlock the transformative potential of this technology to improve lives and foster a more equitable world for everyone. This isn't merely about avoiding harm, it's about actively leveraging AI as a force for positive societal change. Imagine a future where AI-powered tools are instrumental in identifying and dismantling systemic biases within education, ensuring every student has an equal opportunity to succeed. Envision AI in healthcare that provides accurate diagnoses and personalized treatments, regardless of a patient's background or demographic. Picture AI systems in hiring and lending that actively promote meritocracy and economic inclusion, breaking down historical barriers to opportunity. This is the profound future we can collectively create if we commit unequivocally to the principles of fair AI. It requires a paradigm shift, moving beyond simply optimizing for performance metrics to prioritizing ethical outcomes and societal well-being. By embracing diversity in our teams and data, championing transparency in our algorithms, and upholding rigorous accountability for our creations, we can ensure that AI truly benefits all of humanity, not just a privileged few. The journey towards fair AI is ongoing, demanding continuous research, collaboration, and a shared commitment to justice. Building fair AI is a shared responsibility that extends beyond technical teams to policymakers, ethicists, and every citizen impacted by these technologies. As developers, researchers, policymakers, and informed individuals, we all have a crucial role to play in ensuring that AI is developed and deployed for the greater good. What specific steps will you take to promote fairness and equity in the AI systems you build, research, or interact with? Share your thoughts, insights, and experiences in the comments section below. If you found this discussion informative and thought-provoking, please give this video a like and subscribe to our channel for more in-depth content on the ethical implications and societal impact of emerging technologies. Don't forget to explore the curated resources and further reading linked in the description to deepen your understanding. Your engagement fuels this vital conversation. Until next time, let's continue to build a better, fairer future with AI.